Welcome to Shanti-Peace for Mathematics. In this video, we are going to discuss about the differential of two variables. Let us talk about the first differential for one variable. So let y equal to f of x is a real valued function of a real variable x, and suppose that this f is differentiable. So if f is differentiable at the point x, then we know that by definition we can say that f dash of x is exist, which is defined as limit delta x tends to 0 f of x plus delta x minus f of x upon delta x. So as the values of x will change to x plus delta x, the values of y, which is f of x, will change to f of x plus delta x. That can be represented as y plus delta y. So this quantity in the numerator I may write as f dash of x, I may write as limit of delta x tends to 0 y plus delta y minus y upon delta x, because of f of x is y and f of x plus delta x is y plus delta y, that is change in y you will have. So this y will get cancelled out, and so you will have limit of delta x tends to 0 delta y upon delta x. This delta x here, this delta x and delta y are known as a differential of x and y respectively. So delta x it's called differential of x, and delta y it's called differential of y. And differential of x is denoted by dx and differential of y is denoted by dy. So this is the definition or the meaning of differential. It's nothing but the change in x and the change in y. So in the same concept we want to discuss about the differential of two variable. Let us have the z, which is a function of real valued function, which is a function of two real variable x and y, and suppose that this f is differentiable at point xy. Then by definition of differentiability we may write this is as f of x plus delta x y plus delta y is equal to f of xy plus fx xy into delta x fy at xy into delta y plus epsilon 1 delta x delta y into delta x plus epsilon 2 delta x delta y into delta y, where this epsilon 1 and epsilon 2 will tends to 0 as delta x delta y tends to 0. So that is the quantity we'll have. We know that it is change in x is denoted as x plus delta x, and change in y is represent as y plus delta y, and change in z we represent as z plus delta z. So the change in z is z plus delta z to z. Change in x is x plus delta x to x, and change in y is x plus delta y to y. So this is the way the change in x and y is represented. So what we can have, this quantity is nothing but the z plus delta z. On this side we'll have z, and this all the quantity I may write as it is. So that is fx at xy in delta x plus fy at xy into delta y plus epsilon 1 delta x delta y into delta x plus epsilon 2 delta x delta y into delta y. Now you just note that this z is cancelled out, so you will have a change in z can be represented as fx at xy delta x fy at xy into delta y plus epsilon 1 delta x delta y into delta x plus epsilon 2 delta x delta y into delta y. If I call it this is as a equation 1, then this equation 1, its principal part, if I can say this part is a principal part because this part is tending to 0 as delta x delta y tends to 0. So I am calling at this part which we have this, it's called the principal part of this total difference. So this a total difference of z can be represented as the principal part of that. So this principal part, that is fx at xy, and instead of delta x I may just write dx fy at xy, instead of delta y I may write dy, which is nothing but the total differential of z, which is denoted by dz. So this quantity is known as the differential of z. In case of three variable, if you have a function which is w is equal to f of xyz, which is a function of three variables, so in case of this, the total differential can be represented as dw, which is fx at xyz into dz, fy at xyz into dy, and fz at xyz into dz. In case of two variable, the approximation can be calculated as delta z, which is approximately fx at xy delta x, fy at xy delta y. That you can see by this, because if I neglect this terms, then this quantity is approximated by this. If I take the limit delta x delta y tends to 0, this two quantity will become 0. So that's why you will have this, that is a total difference you will get. And if I'm not taking the limit and I'm neglecting these terms, okay, so you will have delta z, which is approximated by this. So that's why it's called the linear approximation or the first approximation, which can be represented in this manner. And if you can consider this delta x and delta y is approximated as dx and delta y is approximated as dy, then this can be approximated as df. So in other words, what we can say is we can estimate the change of delta z in z by value of differential dz, and where dx is a change in x and dy is a change in y. Okay, let us have the example of such type. So this is the problem that I am talking. Example: approximate the value of z, which is x into y square, from the value 0.51. So this is your x and this is your y, to value at this. So the value of x is changing from 0 to 0.5 from 0.503, and value of 1 is y is changing from 1 to 1.004. Compare the magnitude of the error in the approximation with the distance between these 2 points. Here, first of all, what is given is z is equal to xy square. So what is zx? That is y square, and zy you will have it is 2xy. As per the total difference, dz is, you know, that fx dx plus fy dy, that is the formula. You will have fx is nothing but the zx, which is y square dx, plus fy, which is 2xy dy, that you will have. Now the differential, this differential at the point x is equal to xy is the point 0.5 and 1.0. So what is the difference in an x plus delta x and y plus delta y? You will have, that is this point which we have here, which is 0.503 and 1.004. So that's why delta x you will have it is 0.503 minus 0.5, which is 0.003, and delta y you will have it is 1.004 minus 1.0, which is 1.004. So this is the things you will get. Now what is dz? If you can see that in this manner, dz, that is a difference in z, you will get y square, which is this 1. So it is 1 square dz, that is approximated, this is as dz, and this is approximated as dy. So that's why it is 0.003 into 2 into xy. So 2 is as it is, x is 0.5, and y you will have 1, delta y, which is actually 0.004, because 1 minus 004 minus 1 is 0.004. So it is 0.004, and if you can simplify, this is 0.003, and this we can write as, and 2 into 0.5 is 1, so this will be 0.004, so you will have 0.007. so that is the difference in Z you will have if this is the situation is given to you. Now the next question is to find out, so compare, so first approximate the change in Z that we have calculated, change in Z we have calculated. Compare the magnitude of the error in the approximation with the distance between this. So we need to calculate now the difference. What is the difference of error approximation that we got? That means what is the things we'll have if you subtract delta Z and dz. What is this error? We will have this. So dz we have this, and what will be the delta Z that we need to calculate? So the value of Z, that is xy square, is there. So if this point is there, then the value of Z is 0.5 into 1 square, so it is 0.5, and Z plus delta Z, where we have this point that we can calculate, that is Z plus delta Z, it is again Z plus delta Z into Y plus delta Z. So that point is given to you is 0.53 into 1.004 square, and if you can simplify this we can get is 0.50703248 by calculator. So delta Z you will get is this minus 0.5, so it is 0.50703248 minus 0.5, so it will gives me 0.007032048. so that is the actual error you will have, and this is the total difference that we have calculated. Now what is the error we'll have by calculating this quantity? So it is delta Z minus delta dz will gives you 0.007032048 minus 0.007, so that will gives me 0.0000322048. so that is the error term you will have. The question was, compare the magnitude of error in the approximation with the distance between 2 points. So we need to compare this by the distance between these 2 points. So what is the distance between these 2 points, that we need to calculate now. So you know that the points are xy is given as 0.5 and 1.0, and x plus delta x, y plus delta y is given as 0.503 and 1.004. The distance between these two can be calculated as square root of x minus delta x square plus y minus delta y square, which is square root of delta x square plus delta y square, which can be written as 0.03003 square plus 0.004 square, which is known as 0.000025. so that will gives me 0.005, and hence we have the error in the distance, that is dz minus delta z upon square root of delta x square, that is the distance between these two, will be 0.000322048 upon 0.005, and if you can calculate that, this is 0.0064096. so this much approximation is there. So magnitude of error in our approximation is less than this quantity of the distance between these 2 points, that we can conclude. Let's have the another example. So here this is the example, length, width and height of the rectangular box. So that is a rectangular box is given to you. So in this rectangular box, the length, height and width measure with the error of at most 5%. So in this length there is a 5% error, breadth have 5% error and height is also have the 5% error. Use the total differential to estimate the maximum percentage error. So you have to find out the percentage error. What do you mean by percentage error? That is the error upon true value into 100. So this is known as a percentage error, and this is the relative error which we have calculated above. That is a relative error relative to the distance between 2 points that we have measured. Here we need to calculate the percentage error that results of this quantity as used to calculate the diagonal of the box. So here when you are measuring this rectangular box, you have error. So what will be the diagonal of this? So the question is calculate the diagonal of the box. The quantity used to calculate the diagonal of the box. So we need to calculate actually the diagonal of the box. So how to calculate the diagonal of this box? Suppose I am taking as length is x, width I am taking as y. So this is length if I consider as x, width if I consider as y, and the height I am considering as. Then what is the formula to calculate the diagonal of this rectangular box? So the diagonal of the rectangular box is nothing but the square root of x square plus y square plus z square. If that can be easily seen by if you consider this is as a coordinates. So if you consider this is as an origin, then this distance is, if this is x, so this is z, so this is 0 0 z. If this point is 0 y 0 and this point which we have here which is x 0 0, so this is x coordinate, y coordinate and z coordinates, and that can be pull up here. So this is x y z, and so the distance between 0 0 0 and x y z is this, that is under root of x square plus y square plus z square. What we are considering, let x0 y0 z0 and d0, that is the initially we have measured, we have started to measure the actual value of the length, breadth and height of the diagonal is there. This is the actual value we are considering, and the total difference that we are denoting as d, which is of d at the point x0 y0 z0. That means the total difference by difference formula that we can have, this d is now function of 3 variable x, y, z. So d as per the total difference formula, it is fx at dx, fy dy and fz dz will have. Fx according to this, it is the partial derivative of this quantity with respect to x. So that will gives me 2x upon square root of x square plus y square plus z square dx, 2y upon square root of x square plus y square plus z square dy, 2 is also come here, plus 2z upon 2x square plus y square plus z square into dz. So d that is the total difference, you will have x upon square root of x square plus y square plus z square dx plus y upon square root of x square plus y square plus z square dy plus z upon square root of x square plus y square plus z square dz. Now if you will have x, y, z and d, which is the square root of x square plus y square plus z square, a measure and compute the value of this respectively. So that is the delta x, which is the error, will have x minus x0, delta y will have y minus y0, and delta z will have z minus z0. So that is the error term will have. And given that what is given in this quantity is that measured error at most 5%, use the total differential to estimate this. So 5% error is given to you. So we need to calculate, or we have given here the 5% error is there. So that's why we have, it is delta x upon x0 is less than or equal to 5% or 5%. So that's why we can write it as 0.05. So it is 5 by 100 I can say, if I cannot write this percentage here. Then delta y upon y0 is less than or equal to 0.05 in the similar manner, and delta z upon z0 is less than or equal to 0.05. Now once we have this, according to that, using this d, using this formula, that is dd, that error, that is delta x, we approximate this delta x, this by delta y, and this by delta z. So you need to just adjust this x0 here, so we can have this. You just note that in this formula, this 1 upon square root of x square plus y square is common out, so that I am taking common. So this d I can rewrite as 1 upon square root of x0 square plus y0 square plus z0 square. Inside bracket we'll have x0 into delta x, y0 into delta y plus z0 into delta z. Now x0 and y0, so I have this value. So if you can adjust that value here, so this can be rewritten as x0 square plus y0 square plus z0 square can be written as x0 square into delta x upon x0, y0 square into delta y upon y0 plus z0 square into delta z upon z0. So what I did is I just multiply and divide by x0 here, y0 here, and z0 here. Now this quantity I can write as d upon d0. If I can write, then what is d0? d0 is nothing but the square root of x square plus y square plus z square. That is our d. So d0 is x0 square plus y0 square plus z0 square. So if I multiply that quantity and this x0 square root of that one is there, so we can write this is x0 square plus y0 square plus z0 square. And here you will have, now if I take modulus, so that is mod of x0 square into delta x upon x0 plus y0 square into delta y, y0, and z0 square delta z upon z0. Mod is over. Now if this I take modulus inside, then using the triangle inequality we can write this is as x0 square plus y0 square plus z0 square as it is, and this is nothing but the mod of x0 square into mod of x upon x0 plus mod of y0 square into mod of y upon y0 plus z0 square as it is, delta z upon z0 is there. So and this value is less than or equal to 0.05, so that can be written as 1 upon x0 square plus y0 square plus z0 square, and 0.05 is common out from this each and every quantity. So in bracket we'll have x0 square plus y0 square plus z0 square, which can be cancelled out. Finally you will have 0.05, which is the error in total difference you will have. So this is less than or equal to 0.05. So what we can say is the maximum percentage error is 5%. Percentage error is a 5%. Now the next concept that we have is the linear approximation. Suppose we have the f is a differentiable function. It can be very closely approximated by linear function near at the point. Suppose that f differentiable function at the point x0, y0. Then the approximation of this is represented as delta f, which is approximated by fx at x0, y0 delta x plus fy at x0, y0 delta y. It can be written as, this quantity can be written as, since this is delta f, so I can write delta f as f of x0 plus delta x, y0 plus delta y minus f of x0, y0, which is approximately fx at x0, y0 delta x, fy at x0, y0 delta y. As you can write x is equal to x0 plus delta x and y equal to y0 plus delta y if I substitute, so you will have f of xy equal to, or it is approximately f of x0, y0 plus fx at x0, y0 delta x plus fy at x0, y0 delta y. So this is nothing but the first approximation of the function, and it is denoted as L of xy. This is denoted as L of xy, which is the first approximation of the function. It's called the local linear approximation to f at x0, yz, and it is denoted by L of xy. So this is the local approximation, linear approximation is there. Let us have one of the example of this. Let L of xy denote the local linear approximation to f of xy is equal to square root of x square plus y square at point 3, 4. Compare the error in approximation, that is f of 3.04 into 3.98 is given as square root of 3.04 square according to the function 3.98 square by L of 3.04 3.98 with the distance between the points 3.34 and 3.04 3.98. So what is the question is, the function is given to you, that is f of xy is square root of x square plus y square at the point 3, 4. You have to compute what is the linear approximation of this. Compare the error with this quantity, and with the L of xy is the distance between these 2 points. As per the formula, the L of xy is this that we have. So we need to calculate what is fx at that point, fy at that point, and we have to substitute that value here. And what is fx is given to you? Fx is given as square root of x square plus y square. Fx at xy will be x upon square root of x square plus y square, because the derivative of square root is 1 upon 2 and 2 will be cancelled out, and fy at xy is y upon square root of x square plus y square. Now fx at point 3, 4 that we need to calculate. So at 3, 4 it is 3 upon square root of 9 plus 16, which will gives you 3 upon 5, and fy at 3, 4 in the same manner 4 upon 5. Now what is L of xy? As per the formula, it is f of x0 y0 plus fx at x0 y0 into delta x plus fy at x0 y0 into delta y. So for that I need to calculate what is delta x and delta y. What is x is given to you is 3. What is x plus delta x is given to you? That we have given is this 3.04, and y is given is 3.98. So this is 3.04 and y is 4, and y plus delta y is 3.98. So you will have delta x, which is 3.04 minus 3, so it is 0.04, and delta y is 3.98 minus 4, so it is minus 0.02. So if you substitute this value now you will have fx at 3, 4, which is square root of 9 plus 16, which is 5. So this value you will have fx at 3, 4 is 3 by 5 delta x. So we substitute this value here now. So this is 5 plus fx at this, that is 3 by 5 into this 0.04 plus fy, that is 4 by 5. Delta y is minus 0.02. If you simplify this whole quantity, so this will be 5.08 you will have. Use the calculator to compute this. And what is given is f of 3.04 3.98. It is the square root of 3.04 square plus 3.98 square, which is nothing but the 5.00819. This is the approximation you will have, that is L of 3.04 3.98 that we have. So if you compare this to the error, so if I subtract the L of, this is the first approximation that we have, if I subtract with the true value, that is 3.04 3.98, then you will have 5.08 minus 5.00819. So you will have the error, which is 0.00019. So this much error is there. And if you compare with the distance formula between these two, that is the distance between these two, that can be calculated as 3 minus 3.04 square plus 4 minus 3.98 square. That can be calculated as 0.04 square plus 0.02 square, which is approximately 0.045. So this is the error between the distance. If you want to calculate the distance, then this much maximum error will be there. So what I can write, the error approximation is about 0.0019. This is less than 1 upon 200 of the distance, this 0.045 or 8 between these 2 points, 3,4 and 3,04, 3,98. Complete the example. I will suggest you that you can go through the exercise given in my lecture notes. You solve that exercise. So let us recall what we did in this lecture. We have did actually two concepts here. The first one is to find out the total difference. The total difference, if you have a functions of two variable, can be calculated as dz, which is fx at xy dx plus fy at xy dy. And another concept we have calculated is a local linear approximation, that denoted as L of xy, which is f of x0 y0 plus fx at x0 y0 delta x plus fy at x0 y0 delta y. So with this I am stopping here. If you like this video, please press the like button. If you have any comment, suggestion or a question, please drop down in a comment box below. Thank you very much. Bye bye. Sayonara.